you do. Let's try that again.
Do you just grab these?
Yes, everything back there. Are you here for the geometry class?
Yes.
Beautiful. Come on in. Are you Alexis?
Yes.
Very nice. She emailed me and told me she was coming today. Perfect. So a few of you have not done the introduction activity because you have not been on Zoom and you've not been face-to-face. So if you're just listening to these videos, asynchronously is what they call it, not at the same time as the class, then you'll need to do a discussion board in order to get the points for the introduction. So I'll add that on. Let's say, I'll add it into our thing. Let's say it's due next Thursday, September 10th. Okay. Madam Andre, I was about to say, those things over here you probably don't have because those are from Tuesday. Yeah. Okay, so let's say September 10th. So if you are one of my kind of trying to be completely online people, asynchronous, not watching Zoom or anything, then you will need to do that. If you have introduced yourself via Zoom, or if you were here in class and introduced yourself, then you are golden. Don't worry, I already have you marked off. And what I'll do is I'll put that into the grade book as a participation grade so that you can see you have credit. And if you don't have a credit, if you have a 0 there, then that means you need to go do the discussion board. But if you've been here in Commerce or you've been on the Zoom and you did it, you are taken care of. I think, I'm looking at the Zoom, I think everybody on Zoom has had an opportunity to introduce themselves.
Is that for the email portion of the project?
No, that's separate. Uh-oh, something's in the way. That's separate, so that was just introduce yourself in class in front of everybody. Did you do that? You did that, yeah. I'm like, I think you did that. So I don't see anybody on Zoom who looks like we haven't heard from them. They didn't tell us a fun fact about themselves and all that, so yeah, okay. All right, so let's kind of get going. There is a syllabus quiz that's due. I don't remember when. Is it today? It's Monday, Tuesday? Tuesday? The 8th, okay. So there's a syllabus quiz that's out there that's due. There is a homework assignment you guys have now. It's page 124 and 131. That's due on Tuesday, am I right? Yes, good. Okay, so don't forget that stuff is out there. I'll go ahead and write the syllabus quiz. This is apparently my assignment sheet now. What else is outstanding? 1.1 was due today. Is that correct? Yeah. 1.1 and 1.2 due today. Yeah, that'll catch you off at 11:59 p.m. Yes, ma'am.
The topic for the semester-long project you sent
to you. The topic for your project, there's a whole list of those topics. September 10th. Now you can do that either by hanging around after class and telling me, hey, I want this. You could Zoom chat me, hey, I want this, or send me an email. Any of those ways is fine. And I'll allow the first couple of people per topic to pick that topic, and then if I have like a third, fourth, fifth person that all want to do dice, then y'all will have to pick another topic. So that's what we'll do there. I think that's it. Well, that's a lot. That's plenty. Plenty of stuff. All right, plus you're going to do something new today, so that'll be lovely. All right. I think we had started triangles the last time we were meeting, and we had talked about things like the difference between a definition and a conjecture and a proof and a theory. So we're not quite to proofs yet, but as soon as we come back from Labor Day, we will be starting on some small proofs, so that'll be okay. So we're going to work on that, and don't worry because I'm not just going to throw you to the wolves on that. We'll do a few examples in class, and then you'll have a chance to work on it at home. It'll be a project for proof, so you'll have a few weeks on it, not just like 1 week. Time to do those things. It'll be lovely. Okay. But for now, we're still at the middle school proof stage. So we were working on triangle conjectures. We talked about isosceles and equilateral and stuff like that. If you weren't present, then go watch that video from earlier in the week. It was a great one, I have to say. Y'all did wonderful. Okay. One thing that we haven't talked about is the triangle inequality. And I'm going to jump to that one real quickly because your homework for tonight has stuff on it about triangle inequalities, and I'll go through the homework for tonight in a second. So what this says is, say I have some triangle, and I'm going to try to make it a scalene triangle. I'm going to go A at the top, B, and then C. So say I have some triangle, and I'm told the lengths of those legs. Okay. So somebody tells you, hey, I have a triangle and my leg lengths are 2, 5, and 8. Okay. Let's try one that we know works first. Okay. 3, 4, 5. What's that? Yeah, that's one of my Pythagorean triples, right? So 3, 4, 5, it's a right triangle, you're right. And she says Pythagorean triples, exactly. Both of those things are true. So this guy, we know that one works because we actually just happen to know that Pythagorean theorem in there, but there's this triangle inequality thing out here that says, hey, let's see whether or not it works all the time. And so instead of like this would be a squared plus b squared equals c squared, it's similar to that where you're comparing the 3 sides, 2 of the sides to 1 of the other sides. But in this case, what we're going to say is we're going to take a plus b, and it needs to be what? Anybody know? Greater than c. Okay. If it's not greater than c, then I don't have a triangle. That's what's going on here. Sorry. Do you want to go back there? There's a please sit here there. Is it this is your way?
No, I just kind of like blur.
Oh.
It's not your fault.
Sorry. Blurry. Can you see the back one from there? Yeah.
Yeah.
You're welcome to turn your chair. Kind of face sideways with me.
Appreciate it.
Whatever works, it's okay. All right, so if we have a triangle, then this is true for all 3 legs, okay? So B plus C is going to be greater than A, and A plus C is going to be greater than B. So all 3 ways, changing this letter out and having the sum of the other 2 together, okay? So I saw Summer J sitting here shaking her head at me. No, she didn't like what I put up there. So this one, for instance, we know 3 plus 4 is 7. That's greater than 5. 4 plus 5 is 9. That's greater than 3. And what's the other combination? 3 plus 5 is 8. That's greater than 4. Okay, so this one, it works. And we knew it was a triangle. But she didn't like this combination that I gave her over here. 2, 5, and 8. Why doesn't she like it?
3 plus 5 is 7, which is not greater than 8.
Yeah.
Be a triangle.
Yeah. So 2 plus 5 is not greater than 8, and so it's only 7, she says. And so that is not going to be a triangle. It doesn't meet the triangle inequality, so I can't stick it in here. It doesn't matter, by the way, if you had done 5 plus 8 is greater than 2. That's true, right? Okay, and it doesn't matter if you had 2 plus 8 is greater than 5. Also true, right? So 2 of them can work, but the third one doesn't work, so that means this guy is not a triangle. Okay, So you have to check all three combinations. Just having one or two combinations isn't enough, because that third one is the one that could throw you out of being a triangle. So what does that mean for my ABC guy up here? If I had done 2, 5, and 8, it doesn't look like this because this is a triangle. What does it look like? This could be 2. This could be 5. And this could be my 8. Okay. Something like that. It doesn't have to be necessarily that, but 2 is probably the problem child here because he's too short is what's going on. And so the 8 just isn't, the 2 isn't long enough basically to stretch out and reach the 8 wherever that angle is what's happening. And so it's something to do with the angle. The angle here will be such that the 8 is too high for the 2 to match up. Does that make sense? Okay. So this guy is certainly not a triangle because it doesn't meet. Okay. So what's another example of something that could be a triangle, I guess, is the next question. Anybody? You got a triangle for me? Can you make one up and find one? So in your findings, you would have to have an A, so find A, B, and C, so that the triangle inequality is satisfied. You don't always get it from me. Sometimes you have to find it on your own, right? So what could you do to say, let's see if we can create something that's going to be a triangle. You might try picking numbers that are kind of close to each other, okay? So what threw me out on that last one is that the 8 was so much bigger than what the 2 could do for adding to the 5. So maybe start with numbers that are kind of close to each other. They don't have to be all in a row like 3, 4, 5 were, but they could be close. So what do you think? Maybe 5, 6, and 8? Maybe? We can try them and see, okay? So you'll find numbers and you'll just have to try it and see if it works in all of the situations. So try some. 5B equals 6, C equals 8. Now, for this purpose, I'm letting the 8 be the longest. It's the hypotenuse. Even if it's not a right triangle, it'll still be the longest because it's the C. So how do I check?
Plug it into that.
Yeah, we're going to check it in all 3 of them. Okay, so let's do it. What about 5 plus 6? Is that bigger than 8? Yeah. We don't even have to know what it is. We just have to know that it bumps it over. Like 6 only needs 2 to be equal to 8. So as long as this is bigger than a 3 or bigger, well, bigger than a 3, we're okay. All right. So, well, bigger than a 2, because it could be a decimal, 2.2, 2.5, blah, blah, blah. Okay, because some of your homework questions will be. Okay, second one, B plus C, 6 plus 8. Is that bigger than 5? Yep, absolutely. So that one's okay. And then the last one, A plus C, 5 plus 8. Is that bigger than 6? Yep. So it meets all of them. So this is a triangle. Okay. And because my legs are kind of close to the same measurement, it's going to be kind of looking like an equilateral. It's not quite because the 8 is a little longer. We also know that equilateral triangles work, right? So you could have just picked 8, 8, 8. Okay, those 3 will definitely work because any 2 added together is 16, bigger than the third leg. Okay. So the homework that you're going to get for tonight is the 4.1 through 4.3, and I will place it on the D2L so that everybody can grab it. This one covers all manner of triangle stuff, and we had done most everything that's on here last time, except for the triangle inequality. I just didn't get that done, so now we have. So this is determine the angle measurements, okay? So for instance, let's just look at number 1 here. 82 plus 31, and then what's this angle going to be? We don't know, but how can we find it?
We'll subtract those numbers from 180.
Okay, Demondre says 180 minus 82 minus 31. That'll give me this angle right here. Everybody agree? All right, now then what about P? It's got to be congruent to whatever this angle was that we just found, because I heard vertical angles. Everybody agree? And then once I've got that one, I've got another triangle over here. I've got 2 angles. We can figure out the third again by
180 minus 2.
180 minus this guy minus whatever the p-value was, right? So you're going to use all those lovely skills that we've been developing, and sometimes you'll have to use more than one to get to where we want to go. And so that's going to be kind of, okay, let's think about this. Some of it's a bit of a thought process. Notice some of them, like number 4. What's this little symbol right here mean?
Or parallel?
Okay, it is like congruent, but it's parallel in this case because it's on a line, right? So this line segment is parallel to this line segment. What that means for us is that both of these lines, those are what? This is a transversal, and this line is a transversal because it goes through both of them. So then I can bring in all that alternate interior angles and stuff like that, right? Okay. So little notations coming in. If you have a problem with anything, feel free to ask me. Demondre, what you got?
I'm just trying to clarify. I don't know if you really want to go over it, but number 2, I know that it would be an initial 90-degree angle, but that Y kind of looks like it would be an acute angle. Like, I don't know if that's like a printer thing, or do we just mark
Okay,
as a
so
90-degree?
here's where we can't assume. All right. This looks, so what he's saying is number 2 here. This looks 90 degrees-ish, right? Does everybody agree? But we can't assume it until we do what? Actually do the math, right? So let's do that one real quick. I'm fine with that.
Don't pay me no mind.
Number 2. So we know that triangle is going to add up to 180 degrees. I've got a 53. And I'm going to go ahead and do that subtraction. All right. Check my arithmetic always, by the way. And then, because I do tend to make little itsy bitsy things. This is actually going to be a 9, right? So is that 99?
Yes.
So it looks like a 90-degree angle, but it's not quite. And what he said was, whenever you looked at Y, that one looked a little acute, like maybe it was leaning a little bit, and that is what's happening there. So you have to work off of 99 and then subtract. How do I get Y on that one?
180.
Okay, so that is a straight line through there. Everybody agree? So again, I'll use the straight line theorem in this case, or the straight line postulate. And I'll say, okay, or you could call it linear pairs, right? 2 guys that make a line there at 180 minus the 99 degrees. What is that? 81 degrees. So that's your Y, isn't it?
Isn't there something that says in a triangle, the opposite 2 angles will equal the outside angle of the third?
As long as, let me think about that, that's an exterior angle. So yes, you could do that here, for instance. The Y guy is the exterior angle to here. We won't get exterior angles for a while, but if you know that, you can use it. I'm fine with it. So the Y guy here will be congruent to whatever the opposite 2 angles are added together. So that's a cool little exterior angle theorem. Yeah. We're not there yet. Somebody had a geometry class. That's what I think. That's a good thing, though. All right, so we got Y, and then we also need X. So what about that, Demondre?
You would just Add 101 plus 17 and subtract that from 180.
Well, it's 81, right?
Yeah.
So the 180 minus 81, yeah, you went the wrong way on your borrow, I think. I do that all the time. That's why I say always check my arithmetic. Now this should be the 99 degrees, right? And then
You still have to subtract the 17.
17. You didn't do that and get 101, did you? No, that still wouldn't be 101. Okay, I'm just making sure. Like that still wouldn't be 101. 82 degrees. Okay, so here is my x. Everybody always check my arithmetic because I don't have a calculator. I should bring one, but I don't have time. So, all right. So, and in this case, so this is the straight line postulate here, but this is the interior sums of a triangle. You don't have to tell me that now, but when we get to proofs, you're going to need a reason for everything you do. So start trying to identify what is it that I'm using, what property am I looking at, Maria?
You said it was homework. When is this due?
Oh, it's going to be due in 1 week. So
The 10th?
that's the 10th. What else do we have on the 10th? Just the topic? I think that's all. So good. So pay, let's call it a packet. I don't know what to call it. 4.1 through 4.3 to September 10th. Right? So you're going to do those kinds of things, applying those properties that we've been using and all the stuff we've been finding. What you got, Demontre?
I just wanted to know, like, with our scratch work, or did you want scratch work if it was like mental, or did you still want work?
Yeah, so some things you can probably do in your head, like you can see, for instance, if you figured out this angle, then P is congruent. You don't have to do any kind of scratch work or anything like that. There's not a lot of space on these pages. So if you're gonna do too much work, like if you were doing all that I just did, instead of using a calculator, I'd want to see that on a separate sheet of paper. Yeah, I can't fit all that in for number 2, right? It's not enough space. So if you're doing that kind of scratch work, then just do it on scratch paper. All right, so you've got that. 4.2 is properties of isosceles triangles. We've talked about those. I think everybody's probably pretty up on isosceles triangles, but if you have questions, let me know. And 4.3 is about the triangle inequalities that we just went over. So that's the reason I didn't give you this one. You weren't quite ready. I will point out, bless you. We'll go ahead and point out to you, down here at the bottom of the 3rd page, exercises 11 and 12, it says use a compass and a straight edge to construct a triangle. Now, the straight edge part is not a ruler. It can be the edge of your ruler that is straight, but it's not measuring, okay? So don't measure from A to B and say, oh, that's 1.25 inches, so I'm gonna do that. So whenever we get here, whenever you start looking at that, you're gonna have to duplicate that segment. So I'd like to kind of show you how to duplicate real quickly using your compass, okay? So it's not hard, it's an easy skill, but you're gonna have to do that. And what they want to do is construct a triangle with the given sides. If it's not possible, then explain why not. So they're using that triangle inequality thing, okay? So let's go ahead and do a duplicate, just so everybody can do it. Duplicating a line segment using a compass and straight edge. So this is a skill we don't necessarily have, so I want to make sure everybody can do it. So if you don't have one of the safety compasses, then hopefully you have a regular old-fashioned compass that you can play with. I will try to show you how that looks. So what I want you to do is just make a line segment, any old line segment. It doesn't matter how long because we're not measuring, okay? We're just duplicating. So we're gonna call this guy AB like they do in the handout.
So technically, the answers can vary with these problems.
Well, it won't vary on yours because you'll use this line segment that they give you. So act like, what I'm saying is act like my AB is this AB. And then whenever you get to doing it, you'll use their AB. Okay, I'm just showing you how to duplicate, and then you're gonna see if it'll add up.
Our example AB won't be the same as yours.
Correct. It doesn't matter. What matters is whenever we go back in a minute and we compare our original to our copy, those will be the same. That's a duplication, right? Like when you stick something in the Xerox machine, you duplicate it. I'm going to upload the assignment on D2L because I don't see it. Yes, I will. I'm sorry. It's not there yet, but I'll do it after I leave class. So when you duplicate it, then you're going to make sure that they match up, and we'll come back and measure and make sure that we're correct. But normally it doesn't involve measuring. This is just to prove to you this is a duplication process. Okay, so what you're going to do, if you have an old-fashioned compass, then you're going to put the point here on the A, well, either side, it doesn't matter. Okay, and you're going to put the pencil on the B, and you're going to find out how far it takes it to open, how wide that gap is. Okay, and then you're going to put another guy down here. Let's call him A prime. That little apostrophe up above the A just means I'm the duplicate. Okay, so A with an apostrophe above it. Okay, this guy is going to match up with that guy. Okay, so if you're using your compass, then all you do is you put one end on one side and the pencil on the other, and then you make a little arc and make sure that it goes through the end point here. Okay, if you do, then you know you have it open the right amount, and you're just going to do the same thing down below. You're going to put the point here and then make your arc with your pencil, and then you'll connect the two. Okay, if you're using the safety compass, it looks a little bit different. Okay, so we're going to use the very center. See it right here? It's usually got a little brass thing in it. The very center, and put that on the A. And then we're going to rotate our guy around until we find the hole that is the closest to that point. I think it's this one right here for me. So you should be able to see the end point through the hole in the compass. And to make sure, I'm going to make a little arc just like this. See me? Okay, let me move my thing so you can see what it looks like. So that's what I mean by make an arc. It goes through that end point. Okay. Don't lose the hole that you just used. That's the only bad part about the safety compass, especially with kids, is they tend to not remember where they put it. So if you use like vis-a-vis markers or something like that, it normally will leave a little smudge on the hole. That's kind of a teacher trick. Okay, so it leaves a little smudge, so then they know which hole they were using. Sometimes that helps. Okay, but if you count, like mine was the third one off, so I know that's where my hole was. Okay. So don't lose that hole, because now I'm going to do the same thing down below. I'm going to put the circle on my A prime, my copy of the A, and I'm going to put my pencil or my pen in the hole.
The same one?
The same one you used before, because all we're doing is measuring a length here. So think of it this way. For us, and for even a regular compass, that length from here to here is a radius of this circle. Does that make sense? A radius. So this, if I went all the way around, mine you can't see because I'm going to go off my paper, but hopefully that convinces you. If I went all the way around, that would be a circle, right? So the AB, whenever I put the center of the compass on the center of the circle, and then I figure out which point I'm using, that makes the radius. Okay, and that's how long this length is. Yes.
I think I'm confused on how you figure out which hole you're using. Could you explain that again?
You're just going to observe into it. So what you're going to do, so let me do it here. Here was the center. I've got that. I just hold it down. And then I figured out that whenever I move this up, and it's hard maybe to see, let me see if I can zoom in on that. There we go. Okay, so I see the hole right there, or the endpoint right there. Whenever I pulled this down, it doesn't necessarily look like it's exact. Oops. Back on center again. Okay, but whenever I pulled this one up, do you see how the endpoint like fills up that circle? Like I can see it through the hole.
Okay.
Okay, but whenever I pulled this one down, I don't see that endpoint in the hole. It doesn't line up right. So the distance that I need, that's why I knew I needed this hole, because that fills up the circle completely. That's how I figured it out. So I use that hole, and then I just make sure that my A prime is again on the center, and then I use the same hole again. Make another arc. Yes, ma'am.
Okay, I get that whole process,
Okay.
but when I go to the actual like handout,
Yes.
there isn't a point that lines up.
Oh no, is it? Let's see. You know what's going on here? It is like right on the edge. Let me see about this. It is right, oh, that's stinkers. Yeah. So it's right between, there's also holes on the inside on the white portion, not on the red portion. Do y'all see that? There. So whenever I do that, I put the center on the A, and I look at these holes right here, and look, it doesn't quite reach. Okay, this is one of those really weird situations where it doesn't quite reach, but whenever I pick the first hole on this end, that hole's too far. So that's what you're seeing as a problem. So it's actually what's going to happen is it's going to be halfway in between this hole and that hole. That makes sense. It's like right on the line of the circle here. So unfortunately, they made this particular handout. It's right where the measurement would be, right where that circle lines up. So I don't have it. So then I'm like, oh man, what I need to do is I need to mark this guy. And I also need to mark that guy, the inside guy and the outside guy. This is just a weird situation. It won't normally happen that way. And then look at it and see, is it halfway? It looks like it's almost exactly in the middle. So we're not caring that much for the accuracy. So you could kind of guesstimate it's halfway between that circle on the inside and the circle on the outside. It's halfway. But what we were trying to do, so let me do this one with you. What we're trying to do is we're trying to make sure it'll match that inequality thing. So what do I need to do in order to do that? Inequality is, triangle inequality says this length plus this length will be longer than this length. Do y'all think that that's going to work? Doesn't look to me like it's going to be long enough. Okay, this plus this doesn't look as long as this to me. We're going to check it. What I'm going to do is I'm going to add, the BC is probably easier to duplicate. All we have to do is add AB plus BC, right? So let me see if we can do that. BC is not going to be on the line. BC.
And I know you mentioned not to, I guess just for purposes of knowing for our students, why are we told not to like measure it with a ruler?
Oh, okay, hang on to that idea. All right. This is my duplicate of BC. Do you see that? I lined it up on the B and then added the BC. So from here to here is this duplicate. Is that longer than the AC guy? No. So he's not long enough. So we know this isn't going to be a triangle. Okay. So Maria has a question. She says, why in the world can't I just measure those things? Okay. Now, the thing here is it says construct. You see that? So anytime it says construct, that takes us way back to the ancient Greeks. We're going to love them by the time we're finished. So they are the ones who have set the standard basically for geometry. And what they figured out was you can generalize all kinds of stuff if you don't put an exact measurement on it. Okay, so we could check it, so to speak, by measuring here and saying, oh, that guy is a little bit longer than 2 centimeters. AB is. BC is 2.5 centimeters. And so if I added those together, that would be 4.5 centimeters. But look, AC is 6.5 centimeters. So we could check it that way. We know, oh, it's never going to line up. It's not going to be long enough, right? So hopefully my addition here is right around, yeah, right at 4.5 centimeters. But what the Greek said was, once you put a number on that, that's only one particular case. It only works for one particular thing. But if you can construct things, it's generalized. Okay, so that's how we get stuff like I can duplicate any line segment. Okay, I have a starting point and an ending point. So as long as I know how to operate that stinking compass, then I can duplicate any line segment. I don't have to, it doesn't matter if it's 2 centimeters or 5 centimeters or whatever. Okay, so whenever they say construct, that always takes us back to the ancient Greeks, and it always makes us use a compass and a straight edge instead of a ruler. Yeah, it was that stinking word that threw me. That's why I went, oh, okay, we got to show how to do this. Now my guess is this one's going to work. Why do you think this one's probably going to work? Yeah, they're closer in size, right? There's nothing crazy long going on here. So it's easy to add just a little bit to, for instance, PQ and be longer than QR, right? So we know that those are probably going to work. But you'll have to construct it and see. You can just do the duplication. This guy, the AB plus BC, isn't long enough. It's not greater than AC, right? So we're done. We don't have to do the other two constructions. We don't care about those. Any one counterexample, we're out. Yay. Well, that was a fun detour. We'll have an entire project on constructing things. Which means we'll have an entire probably week or so where we spend time doing that for realsies. All right, so we'll spend probably a week or so doing constructions, and then they just keep on coming up throughout the semester. We're not going to like, oh my gosh, we've got to do all these right this second, different constructions, but that's an easy duplicate a segment, and that gets you started with those safety compasses, or with your regular compass, making sure you know how to place it and make the arc, and then just with a regular old-fashioned compass, what I have found is I'll place it and I'll get the right measurement, and then when I pick it up, the whole thing moves somehow. So it's like, ah, stop it. Just beware of that. Okay, so there's your next homework. I think you have all the skills you need for that, so you can work on it. It'll be good. The one after that is about triangle congruencies, and we're not quite there yet. So if you're here today and you won't be here on Tuesday, you can just hang on to that one, and it'll be due probably a week from Tuesday-ish. We'll see how far we get. All right, that was fun. Was it okay? Yeah, we love geometry. It's great fun. All right. Let's talk about triangle congruencies. That's where we left off the other day. Okay. As I recall, we had said things that are triangle congruencies are side, 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 and we showed that one, right? And there was another one we'd already done. Okay, side, angle side, 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 side. Oh, and we talked about angle, 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 but what about that guy? Oh. Similar, but not congruent. Angle, angle, angle. Good. Okay. I think those are the only three we talked about so far. There's some more combinations of sides and angles that are out there. So what do we think? You know another one that does work? We'll talk about the weirdo last. I'm going to talk about, and sometimes in your book it'll be called angle, side, angle, or sometimes it'll be called angle, angle, side. So we're going to do a picture of one of those and see what that looks like. We can do it. So either one of those has two known angles and a side. Side, angle, 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 side. Oh, you said angle, angle, side. Good job. Alright, so that case gives me two angles, but here's the deal about that. We just saw in the homework that's due a week from now, if I have two angles, what?
Then you can find the third one.
I know the third one, right? That's that third angle conjecture that we already know, because we know it adds to 180 degrees because it's a triangle. So if I have two, I can find the third. So this forces the third angle. Okay. But the reason it's different from angle, 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 angle was just similar, right? But the reason it's different is because it has the side in there, okay? So it's only telling me two angles, but we know the third one. It's out there. It's forced, okay? So I really have three angles and a side. Now, if we had done, whenever we were doing our angle, angle, angle stuff the other day, if I was doing that equilateral triangle, for instance, and I said 60, 60, 60, and you have to have a 2-inch base, then what would we see whenever we compared? All of our sides would be the same because we forced it, that one side, and then the two angles, okay? So in your book, let me see if I can find that one. It's in the other section. I went backwards, of course. And we'll do a lot of practices with this and be okay. All right, here's my picture. It says, it looks like this. What did I do? I was up to D, E, F. Let's do G, H, I. We've got this guy. They look the same, but I can't assume. Okay. Until I tell you that angle I is 30 degrees and angle L is 30 degrees. And then I tell you that angle K is 50 degrees and angle H is 50 degrees. And then we put these guys as congruent. Okay. Now remember that whenever we call these, we just like follow it around. Okay, so I'm going to follow around on my triangle, and as I go through the parts, I've got an angle, I've got a side, I've got an angle, a side, an angle, a side. I make sure that I call them in the order they need to be touching, right, in order for this to work. So this is angle, side, angle. Okay. And they're all touching, so yes, that truly meets that. If it had been this guy over here, then it would have been angle, angle, side. It still works out the same. That's why they put these two together. So angle, angle, side, because like, what's this guy up here? Do we know him? We can figure him out. 100 degrees, everybody agree? Ashley says 100 degrees, all right? So that one is forced, so we have the three angles. We know these are similar, but then whenever I look at it and I've got these the same, let's say, I don't know, it's 3 centimeters. It doesn't matter what the length is, as long as they're the same, they're congruent, okay? And I say, okay, what about the other sides? Okay, and by the way, what I started to say was, it could have been that I knew the 100 and the 50, then it would be angle, angle, side. It works out the same because instead of forcing this angle, it would force this angle down here. Same thing. So that's why they put these together. All right, so now what? What about those other sides?
We have to use cosine.
Okay. To figure them out, yes, I would need to use some trig or something, right? And you could use law of sines here. I'm not going to do law of sines because that's not the point of this class. But yes, you could totally use law of sines and get that figured out, the side to the angle, the side to the angle, right? Okay, so, but I don't need to know their exact measurement. What I need to know is, are we convinced that they're congruent? So for instance, GH is in the same position as JK. Does everybody agree with that?
Mm-hmm.
When they're in the same position, when they were on parallel lines, we called them corresponding angles, right? So now that I'm in triangles and their sides or legs, I'll call them corresponding sides of the triangle or corresponding legs of the triangle, okay, because they're in the same position. So GH and JK correspond. Are we convinced that they're the same measurement is the question. Do we need to do a patty paper proof to prove it? Nope. You don't need to see the patty paper? Aw, I like the patty paper. So if you're not sure, here's what I say. Go out and create these sides, these two angles in this side, okay? And then figure out, here's what it'll look like. Let me get you this. You've got a 30 degree, you've got a 50 degree, and you've got a 3 centimeters, okay? Those are anchored, so to speak. They're not moving, they're stuck, okay? Once I have those, we don't know this side and we don't know this side, but what we know is they're gonna meet somewhere up there and they're gonna make an intersection point, okay? Something like that. That doesn't quite look like the one above it, sorry. My angles aren't the same. But, so they're gonna meet up there and we know that this angle is going to be forced, right? So if I do this once on patty paper and Ashley does it once and she's got the same 50 degrees and the same 3 centimeters and the same 30 degrees, are they gonna meet in different points? No, they have to meet at the same because this angle is pushing this one this way and this angle is pushing that one that way. So we can do that with our middle school kids and we can have them all make the required angle side angle and then meet them up and then overlap their patty papers with each other and make sure that they match. They will, okay? So they're gonna match. So what we say here is this corresponding side is congruent to this corresponding side. I'm going to put 1 hash mark on them. Okay. And then GI corresponds with JL. Okay. And those are corresponding parts. And since we said we think these are congruent triangles, then guess what? Yeah. 3 hash marks for you. I already did 1 and I already did 2, so he gets 3. You could do other things. You could do the little lightning bolt or the squiggle or whatever, just as long as your congruency marks match, you're okay. All right. Okay, so that tells me Mary was correct. Angle, angle, side, or angle, side, angle, that is a congruency, triangle congruency. Okay, so we've got it in our list right here. And that's 5 of them. There are 6.
ASS.
ASS. We actually, whenever I was a kid, that is the way that my geometry teacher taught it, was ASS. And of course, we all had so much fun. So nowadays, you won't see that anymore. In your geometry books, it will almost always say SSA. But I always tell people it's the bad word. Spelled backwards, okay? It's the one that could be the bad word. And because it could be the bad word, he's actually the one that causes problems, okay? So this is not a congruency triangle. A triangle congruency. It's not, okay? Bad word doesn't work. So what happens is there's actually only 2 that don't work. Okay, all the others will get you congruent triangles. If you've got side angle side, two triangles have side angle side the same, then those two triangles are going to be congruent. The ones that are bad are angle, 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 and side, side angle. Okay, so we're going to talk about side, side angle a little bit. Okay. All right, so let's look at that one. He's the tough one. Side, side angle is not a triangle congruency because this is the ambiguous case. Anybody remember that word from high school geometry? Ambiguous case. What does ambiguous mean? Can't. Nobody knows what ambiguous means?
There's not a clear answer.
Okay, it's an unclear answer. Not certain. I need water. Okay. Ambiguous. If you're ambiguous, it means like there's a party Friday night and I really want to go because I want to see my friends, but I'm really scared because COVID. Sorry, have to throw that one in. So I just can't make up my mind. I don't know what I want. I'm ambiguous about it. I could do this and I'd be happy, or it could be this and be unhappy. Who knows? So if I stay home, it's going to be boring. And by the way, don't go to that party. In case you're not sure what the right answer should be, please stay safe and don't go to your party. I'm sorry. So that's ambiguous. I just can't make up my mind. I don't know what's going on. It could be more than one thing. I'm not sure. It's not clear to me what I should do. Okay, and that's what happens with the ambiguous case. Whenever I have side, 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 side angle, okay, it looks like this. This guy, and this guy. Okay. The problem is, I don't know. Okay, I've got the angle way up here, and it's kind of dangling. Do you see that? So the problem is, I don't know how far out that extra leg goes. It could be that it goes way out here, and this is a really long, crazy scalene triangle. Or it could be that this side meets here. Well, it would have to be straight, sorry. Something like that, okay? So I don't know what's going on, and the problem is that that angle just kind of has a side that's dangling out there. It doesn't, I don't know for sure. And what should be locked, so to speak, what should be anchored for me is this angle here. Okay, if this angle here was set, then I'd have side angle side, right? Which we already know that one works. And then I would be forced for this guy to not move. But this guy, he could come like this, right? Let's see, that's a much better picture than what I had. There we go. He could come like that because the angle is not set, okay? As long as the side is the same length, it doesn't matter. I'm a terrible artist, so I don't know why they put me in geometry ever. But that's the idea behind it. Let me show you a better picture, much better picture than mine. It's in your book. It's on page 221 if you've got your book. That's a much better side picture. So see, this angle is set. This side is set. This side is set. But this angle here isn't anchoring anything. So we can swivel this guy around however we need to. And if this side comes out, you can see, depending on how big this angle is, it could meet here, or it could meet way out there. And in fact, there's actually a third option. It could not meet at all, okay? Because this angle could be right here. If this side isn't long enough to reach all the way to that other side where this guy's angle set, then it won't ever actually touch, so that it doesn't even make a triangle, okay? So that's why they're called ambiguous, because it could be, somewhere I have a really good picture of this, I'll try to dig it out. 0, 1, or 2 triangles. Okay. So the case where it doesn't even meet, like, that. If it doesn't even meet, that's 0 triangles. It could be you really do have the same exact triangle. They really are congruent, and then we'd be great. That'd be lovely. Okay, so it could be that it works, that they match, but I could have that 2 triangles making. Okay, and it's special situations where that second triangle meets. Okay, and if you take a trig class, okay, this makes me 2 triangles, right? Okay, so sometimes it's 2. If you take a trig class, then you'll go through the actual process of figuring out when does it make 0, when does it make 1, when does it make 2, okay? And basically what happens is you figure out this angle down here and say, okay, that's 1 triangle, and then you subtract it from 180 and you get the other angle, and that makes it a bigger angle. So yeah, fun stuff. We're not doing that in here, okay? But if you take a trig class, you'll figure that out. For our purposes, we don't need to know that. For our purposes, I just want you to be able to look at, say, a picture in your homework set and see, look, they're giving me this triangle. What am I up to? JKL. Okay, how about MNO and PQR? MNO and PQR. And we kind of think that those look the same. And as we go through and we see stuff, we see, oh, we have side-side angle. So I have this lovely picture, and that's all they're giving me. So your job for this would be to look at it and say, oh, wait a minute. Let's follow that around. It's side and then angle. This is the bad guy, right? Not a triangle congruency. You gotta recognize it. You gotta be able to follow in order, know that this is side-side angle, and then say, oh, look, that just doesn't work for us. It's a side-side angle, so not a triangle congruency. That's the bad guy. Okay. And angle is not a congruency, but I won't call him the bad guy. He's similarity, but he's just not congruent. I just don't have quite enough information to force it to be congruent. Okay. We're gonna come back on Tuesday after the holiday. The holiday doesn't really affect our class very much. You're already on Tuesday and Thursday. So we're going to come back on Tuesday and we're going to work a whole bunch of problems, and y'all are going to tell me which of these applies and which of these doesn't. Okay? So what I'd like for you to do over the weekend is to kind of look at it and make sure that you understand how to trace that triangle, which parts line up with which parts, what are corresponding pieces of this triangle to corresponding pieces of that triangle, and be able to know, okay, NO corresponds with QR here, right? Even if they're flipped weird. Okay, so I just saw one, for instance. This picture up here. I'll have pictures ready for next class period. These look like these big triangles here are congruent. CRO and ROW look like they're congruent. So what we're going to do on Tuesday, I just don't feel like I have enough time to dip into this too far. But what we're going to do on Tuesday is we're going to figure out whether or not they are congruent, and then we're going to apply all that stuff we've been working on. Okay. So there is something that's called corresponding parts of congruent triangles. Once you know two triangles are congruent, corresponding parts of congruent triangles. So for instance, that would be angle O corresponds with angle R. And those are corresponding parts. Okay. This, we end up calling it CPCT. Corresponding parts of congruent triangles, because it's just so long. Okay, so use one of our congruencies to figure that out, angle inside angle or something like that. Then guess what? All those corresponding parts automatically congruent. Okay, because they have to be, if the overall polygon is congruent, then for instance, P has to have the same measure as M because they're in the same spot, same position. Okay. So they are congruent. And that little guy right there, corresponding parts of congruent, it'll go on to be quadrilaterals, corresponding parts of congruent hexagons, corresponding parts of congruent whatever, any kind of polygon you got. Anytime you know they're congruent, guess what? All their corresponding parts, also congruent. And they'll stick with us for the rest of the semester, so you better become friends with him. Okay, CPCT, he's gonna be our friend. In this case, the T just stands for triangle. If it was polygons, it would be CPCP. All right. Everybody good? I thought roll real fast because I did not do that yet. I'm sorry. I just got sidetracked. Then I shall. Off Amanda. Maria's here. I saw Christina. Dave here. Gabriel. Oh my God. Okay. Alexis is here in person. Yeah. Jessica's on. I see you. Summer J, I see. Matthew's here in person today. I don't see Caroline. Mondre is here. I don't see Summer. Elijah is here. Everybody is here. I got Ashley. I got Mary. I got Ryan. No Garrett and no Cameron. Okay, so what I'm going to do is I'm going to let this thing do its spooling, and I'll load it as soon as it gets there. But before that happens, I'll load up all the documents for you guys, okay? The video, I'll have to let it spool. So as soon as it does that, I'll get it loaded too. All right? Have a lovely weekend. Thank you, guys. Everybody take care. I'm stopping the recording now.
I was going to say, I haven't actually got the page 1 through 4.